Alright, very good day. Welcome to Math Your Instincts. And here we learn to math. We learn to math for instincts. So there's no formulas, no memorization. Just do it by your instincts because it's the most powerful thing ever. So now, as you can see, if you click this video, so I'm going to imagine. Let's start by doing a warm up, shall we? So let's try dividing, or we're gonna try divide 10. Or we're gonna divide 10 by, let's say 3. Okay, so what is the highest factor we can do with 3? Well, 3 times 3 is 9. So we will get 1 as a remainder. 3 will be the factor. 3 will be the factor. And 1 will be the remainder. Alright. So now we're going to learn how to divide functions. But not yet. We're going to do another one. So first thing, we're going to divide 100. Let's say just a prime number, for example. So let's say 107 divide 6. Okay, so what we can do if we start to divide by a large number, there's no way we're gonna find something so large that it can divide 6, right? Well, we can start from here. So what is the multiple of 6? So we start from the hundreds, but 1 is less than 6, so clearly it's not divisible. So we're gonna move another one. So is 10 divisible by 6? Yes, 1. So it will be 1. So this will be 1 and 40 here. 60, sorry. Oh. So this will be 60. And this will result in 47. So what is the power of 6? What is the factor of 6 that we can get so that we can get 47? So if you think about it, 7 times 6 is 42. So the highest possible is 7. And 17 will be the factor, and 5 would be the remainder. Alright, so what can we observe from this? Well, we can know that the factor is 100% something that is an integer. Yeah, it's always a number, an integer. And the remainder is also always a number. Sometimes the factor can be a real number, such as like you divide what? You divide 5 by square root of 3. Well, yeah, this will be kind of difficult thing to do, but you can do this. And we're just gonna get 2. Yeah. And 2 is still a little bit less than the remainder of 3, so I'm not gonna continue this. But you know the drill. Yeah. Okay, so anyways, we have 17 as a factor, 5 as a remainder. So what can we apply this if we see functions? So let's start off easy. So we have x squared plus 1 divide x. Yeah, let's just start easy. Let's just start very easy. It's very easy. You can imagine this. This is also equivalent to this. Yeah, so this is an improper fraction. We are dividing an improper fraction. Because the power is higher than the denominator, the denominator power is higher than the denominator. So this is not a proper fraction. It's like a 45 divided by 7. Clearly this is not a proper fraction. So I mean, there's a fraction, but the denominator is bigger than the denominator. Yeah, so what we're gonna do is we're gonna find the highest power. So what we can do to the x. So let's try and multiply by x. So the same thing, we multiply by x, we get x squared plus 0. So this will be our remainder. So we're gonna minus, and this will be x squared by x squared will be 0, and we will only have 1. So what is this? X is the factor. 1 will be the remainder. So how can we write this into something that we can do like this? Well, actually the same, but instead a is not a number. A is the factor and b is the remainder. So from what we know that this is a factor, and plus remainder over x. Like something, this x, this is the what we divisor. Let's say I'm just gonna call it divisor. This is the form that you need to remember, or basically just common sense. Yeah, this is just common sense, because you want to divide x, want to divide 7. Yeah, so let's say, yeah, so this is just the same thing right here. So if this is a factor, this is the remainder, then this is the divisor, because you divide 107 by 6. So this is the divisor. Alright, so clearly we can see the factor is x. The factor is x. So this is the factor, and remainder is 1, divisor is x. So what is this? This will be x plus 1 over x. Simple, right? But if we didn't use this, we can actually just cancel out and just split this into this. So this is the second method. You can also do this, but I want to teach you how to do the fractions easily. So yeah, I'm gonna start off easy for real. So this x squared divided x clearly is gonna be x, and this will be the same result. So let's try a little bit harder. Let's try something harder. So what about x squared plus x plus 1 divided by x minus 2? Right? So this will get a little bit tricky, because yeah, it will be a little bit tricky. So bear with me. So the first thing we're gonna do is we're gonna try to cancel out the x squared. We try to cancel out the highest power over here. So what can we do to this divisor so that it is the highest power? So clearly we're gonna multiply this by x. So after we do this, we're gonna multiply x by x minus 2. So what we have x squared minus 2x. Alright, so far so good. And we're gonna minus this, because you know, right, like if you do the division, you minus this term. So 107 minus 60 is 47. So the same thing over here, the x squared plus x squared plus x plus 1, you minus this whole thing, and the x squared term will be cancelled out, and x minus 2x will be 3x plus 1. Right, so is this less than this? Is 3x plus 1 less than this? Can 3x plus 1 be the remainder? No. Why? Because the remainder must be a number. We have x on it. We still have x. And in this case, x is our divisor. So the x has the same power as the divisor. So this means that this must be the way we can further simplify this, right? And right, that's right. We can multiply by 3. So we're gonna add a plus 3 over here. So now we have 3x minus 6. So the same thing over here, 3x minus 3x over 6 cancel out. 1 minus 6 is 7. So what we have here? So we have, we're gonna write it again, x plus 3 factor. This is our divisor. And this is our remainder. Not so easy now, isn't it? But it's okay. Once you get how the division works, it will be quite easy for you. You just need some practice. So we can know that x squared plus x plus 1 divided by x minus 2 equals to this formula over here, or it just basics. So we have x plus 3 plus, what's the remainder? The remainder is 7, and the divisor is x minus 2. So you get a quite wacky formula here, or an expression. Yeah, because you're dividing a quadratic, you're dividing a quadratic by a linear function. So the highest power must be a linear. It's like 2 minus 1 is 1. Yeah, it's like you divide 100 by 10, you're less a 0. So pretty much the same thing right here. Like divide x squared over x, you get x. You're dividing x power 4 over x squared, you get x squared. Pretty much the same thing over here. So sometimes the remainder, not necessarily in this context, in x, the partial fractions, the remainder can vary. The remainder sometimes can be in terms of x, but unless, so I'm going to show you what is a remainder actually. What do you know about remainders? So you know that the remainders in fractions. Alright, so then we're gonna return to the fractions again. So let's say a over 3 again. We have 2 plus 2 over 3. So this 2 is a factor. This is a factor. This is a remainder. And this is a divisor. Right. So but in fractions, in this polynomial thing, the definitions of the definition of factor, remainder, divisor are different. I mean, the factor and divisor are technically the same, but the remainder is what makes it different. So based on what we know fractions, we already know that the fractions in the polynomial, it actually depends on the power. What's the power? N. This is the power. This is the power that we're looking for. So let's say if we have x cubed, this is the power. We divide by power, so we have x. So this is the factor. This will be the factor. This is the divisor. So as you can see, if sometimes I have x squared, so now I have, how am I gonna explain this? Alright, so I'm sorry about the confusion just now. Alright, I'm sorry. I'm gonna make it clear right now. So the remainder in polynomial, it depends on power. So if the highest power of your divisor is So if your polynomial is like your, let's say fx, yeah, because yeah, the remainder. So if the remainder, the highest power remainder, so highest power, so highest power of remainder, if the highest power of remainder is less than the highest power of divisor, then this is a remainder. Yeah. If you divide everything and you still you divide and keep dividing, keep dividing until it was less than the highest power of divisor, then this is a remainder. Alright, so for example, you divide something by x power 4. What's the possible remainder? So first we have x cubed as a remainder. We're gonna make it clear. You divide something by x power 4. So the remainder can be x cubed the remainder can be x cubed, can be x squared, can be x, can be 1. Depends actually. Because our goal of this, if you want to turn an improper fraction into a proper fraction. What that means is, let's say we have x power 10 over x power 4, and this is clearly improper fraction, and after I divide it, I get x power 6. Now this is a proper fraction. Why? Why this is a proper fraction? Because it's not divided by anything, and it's like 1, but it's not 1. It's like a full number in this case. So I hope it's not confusing. So anything, if you divided something by x power 4, your remainder can be something, can be kx cubed, kx squared, kx, or 1. K is an integer. K is your factor. Yeah. And I'm not gonna say integer, I just say k is real. Yeah. So yeah. So let's see some cases from this. So what are the cases? So I'm gonna give it another example. Let's say x cubed plus 1 divided by x squared plus 1. Alright, what about this? Okay, so we're gonna go through this step by step. So what can we do to this x cubed plus 1? Alright, let's make this harder. Alright, x power 5. Alright, so what can we do to this x squared plus 1 so that we can make it divide x power 5 plus 1? So clearly we're gonna multiply x cubed. So now we have x power 5 plus x cubed. So the same thing, we're gonna minus this whole thing over here. So this term we can cancel out, and what we left is negative x cubed, and this one will be bring over here. This one will be bring over here. So we have plus 1. We still have the plus 1 over here. So now we have x cubed plus 1, and then we have negative x cubed plus 1 over here. So what can we do? Well, we can minus x. We can do a minus x. Oh wait, this is mixing with this. Alright, better. I'm gonna draw a line. Right, so we can minus x. Why minus x? Because we have negative x cubed. So we have minus x times x squared plus 1. So minus x times x squared is negative x cubed, and minus x plus 1 is minus x. So this will be, so if we like, we're gonna minus this, and this term will be cancelled out, and what's left is x plus 1. So now we stop. This is the stopping criteria. Why? Because this is the power 1, this is power 2, and power 2 is greater than power 1, and because of that, this is the remainder. So I'm gonna label it again. This is the factor, this is the remainder, and this is the divisor. Right? So this is the divisor. So what can we conclude from this? We divide x power 5 plus 1 over x squared plus 1. So this is the improper fraction. We need to make it a proper fraction. So we need to divide everything into this. So we get factor plus remainder over divisor. Our remainder is x plus 1, and our divisor is x squared plus 1. Nice. So that's all what we do. Even though you have an x over here, but as long as the power is not square, it's okay, because it counts as a remainder as long as the power is less than. So a very clear example is 1 over x. So you see, 1 is x power 0, and x is x power 1. So this is a remainder, while this is a factor. You see, it's definitely less. It's less than 1. So I hope you are clear now. So that's why 1 over x is the simplest form. You cannot further divide the 1 into something else. I don't even know how. Yeah. So if you forgot about the remainder and factor, think about the 1 over x. This way, alright? Alright, so now I hope you know how to divide a fraction now. So here's a special one. Alright. We're gonna experiment a bit about x power n plus 1. So so everything after here is just pure exploration. So you might discover that x cubed plus 1 is 1 plus x plus 1 plus x squared plus, there it is. Oh, am I doing it right? Maybe, but we're gonna find out, and we're gonna verify eventually. Yeah, so we got a pretty much interesting pattern over here. So now I'm gonna try to divide. So let's say what if x is some odd number n. So now I'm trying to divide the odd number n plus 1 with x plus 1. Yeah, so this is like factoring. Yeah, because if n is odd, then negative 1 plus 1 is 0. Whenever n is odd, so that we can substitute 1. So yeah, the goal is we need to divide this. So what we can do over here, so we know that, what can we do to this thing so that we can get x power n? Well, clearly it's x power n minus 1. So from this we can get x power n plus x power n minus 1, and this gonna oh wait, there's no space. I'm gonna move this to the next page. Alright. This is so difficult to write word. Ah, dang it. Alright, much better. Okay, so now we have xn power n minus 1. So this and that will cancel out. And what's left would be x power n minus 1 plus 1. The same thing, we're gonna add x power n minus 2. There'll be x power n minus 1 plus x power n minus 2. And this will be repeated forever. So what we know, until we get a factor, we'll eventually get yeah, since this is an infinite sum, we're not gonna get a remainder, which is kind of very weird here. But now what we know is, if we divide x power n plus 1 over x plus 1, we will get an infinite sum of x power n plus n minus 1 plus x power n minus 2 plus x power n minus 3 plus dot dot dot. So what's x power n plus 1? Well, this actually is equal to x plus 1, and then multiply the whole thing. Copy, wait, paste. Right. Cool, right? That's how they get. That's how they can. Yeah, that's how they can write x power 7 plus 1 in a matter of seconds, because it's literally just x plus 1, and this will be x power 6 plus x power 5 plus x power 4 plus x power 3 plus x power 2 plus x plus 1. Yeah, that's how they do it. So amazing, right? So I hope you learned a lot from this video, and the next video we're going to talk about the factor theorem and remainder theorem. So stay tuned and have fun. Yeah. Lastly, we need to do math based on your instincts. Don't memorize formula, understand it. Concept is everything. Yeah. Bye.